Hi, welcome to this first in a series of live sessions about the upcoming Carbon Hack, which I'm very excited about. Carbon Hack for the Green Software Foundation. My name is Asim Hussain. I'm the Executive Director and Chairperson of the Green Software Foundation. And I'm just really excited. We now have another Carbon Hack. We ran Carbon Hack in 2022, and we're now ready to run another one. And in this session, I'm going to talk to you a little bit about Carbon Hack itself, what to expect, a little bit about sponsorship, and then I'm also going to talk to you about Impact Framework, which is the open source tool that the hackathon we're running is going to be all about. So, feel free to ask any questions. I'll see if I can answer them live, or I'll try and answer them at the end. Or if we don't get time, we'll make sure we reach back out to you and get you your answers. But let me dive in. Yeah, and sign up to the hackathon. That is our URL, grunstuff.org hack24. The website's live, so please feel free to go and register your interest to participate in the hackathon. Little fact, it starts on the February the 26th, and it finishes on March the 15th next year. So let me talk a little bit. So what are we talking about here? Carbon Hack this year is all about measurement. All about measurement. If you heard me talk over the last year, all I really talk about is measurement. Measurement is key to decarbonizing software. But until now, no solution has really been available to allow you to measure, software's environmental impacts across the whole spectrum of what we need to measure. That's what we in the Green Software Foundation for the last year. A team of people from across multiple organizations have been working on an open source tool and set of standards called the Impact Framework. And this is again going to be the focus for the hackathon, which again is from February the 26th to Friday, March 15th. And we'll be giving you lots more information on that on this session and also future sessions, because there's a lot to go through. It's a hackathon. So it's a hackathon. So it's an experience. It's a friendly competition, healthy rivalry, hopefully a lot of collaboration, and we're really hoping that you'll push the limits of the framework and really help us to grow the ecosystem for software measurement. So solo or in small teams, we want you to build plugins for Impact Framework. We want you accept enhancements to the framework itself by contributing code to the CLI tool. But also this year around, we really want to open the door to more non-technical contributions. So there's also prize categories for content. So if you're creating content, written, video, whatever, anything that helps people understand and explain and learn and know how to use Impact Framework and software measurement, that's also a category in the hackathon for this year, also for 2024. I do want to just briefly talk about sponsorships. We have a number of sponsors in the pipeline right now. And sponsorship for this year is 5,000. It's the flat fee, 5,000 sponsorship. And if you're interested in sponsoring, I'll give you some links later on. But you get one seat on the jury, you got a logo on the hackathon site, you get featured, you mention in social media. But more importantly, if your organization is interested in measuring, or you have a specific type of challenge regarding software measurement, I recommend you sponsor. We'll bring you on these live sessions to talk about what your challenges are with measurement, and hopefully through the hackathon, we can find solutions. So this is something, if measuring is something that's important to you, if you have challenges in this space, reach out, sponsor the hackathon. And this is how we're going to help you to solve your measurement problems. And it's also going to help us and help the community to grow and become a lot better at software measurement. We have last year we had just one prize category. Now we've got multiple prize categories. There's multiple different ways that you can win in this hackathon. We've got the best model, and I'm going to go through that in a lot of detail. There are these Impact Framework is all about building these things called micro models, these model plugins. We need a lot more of those to be built. So there's a prize category for the best model plugin. There's a prize category for the best contribution to the framework itself. So we want you to contribute to the actual CLI tooling and other aspects of the framework itself, including documentation. We want you to contribute to the framework. Again, I mentioned before, best content. We need people to know and this is a very new idea, impact framework. So we need to help people understand how to measure, what to measure, how to use the impact framework. So there's also a best content prize category. It's a non-technical content. So if you're not somebody who's very if you're not a developer, if you're not comfortable, or you just feel you're better at writing content, there's a prize category for you. I'm very excited. I'm very excited also that this year we're going to be introducing a category of prize called Beyond Carbon. It's called CarbonHack, and a lot of our focus in the foundation is around carbon. But we do, I personally, and a lot of people want to start moving the conversation beyond carbon. Using Impact Framework, you could actually build plugins that help you to measure different things: water, waste, air quality. We need to start moving the conversation. The world's ready now to start moving the conversation beyond carbon. So these are some of the prize categories we have. There's also a couple of other prize categories. So we really want to drive, contributions from people who are earlier in their career. So we have a best undergraduate prize category. So if you're an undergraduate at university, there's a prize category for you. We're just figuring out the details. I don't want to put it on this slide right now, but we're just figuring out the details, but we're trying to launch an under 18s category. So the best contribution from a team comprised of people who are all under 18. We need to move forward. We need to be talking to people who will be the leaders in 5-10 years time. So we're just figuring out the details of that. Hopefully we can work it out, and we'll be sharing that as well. So that hopefully, fingers crossed, there'll be an under 18s category as well. If you are sponsoring, the question that comes up quite often is, yes, if your organization sponsors, you could still participate. We have a process where, because a sponsor is on the jury, if you work for a company and somebody from your company's in the jury, we just ask them to not, participate in scoring your application or your contribution. But you can sponsor and participate at the same time. Important dates for sponsors and just for everybody. We're announcing it now in December. Will there be lots of further communications and teaching and education training? We're going to start, the hackathon begins on the 26th of February. We're going to help you, we're building out the hackathon platform right now. There'll be methods, and you can come solo. If you've got an idea and you don't have a team, you want to form a team, we'll be able to support you in forming a team. You can come with a team fully formed and an idea fully formed, and you're ready to start hacking. That's fine as well. But we're going to help multiple different types of people to engage in the hackathon. Again, hackathon begins on 26th of February. It ends on the 15th of March. And then we've got a judging process, and then finally an award ceremony on the 27th of March. Yes, there is a document. I'll just talk very quickly. There is links and documents that we can share in a second. Highlights in the previous CarbonHack. We ran the first CarbonHack in 2022, and it was centered around another open source tool that was built in the foundation called a CarbonAware SDK. The event was a breakout success. We had 400 participants, 400 individuals hacking, and there were 51 solutions submitted by the end of the whole process. We had lots of great sponsors. We had Accenture, Avanade, Gamma from BCGX, Globant, Goldman Sachs, Intel, ThoughtWorks, UBS, VMware. These are the last hackathon sponsors. And these are the first. The first place was Low Carb. The first two places were around machine learning and CarbonAware, and the last one was Circa, which is a CLI tool, which I really love that tool, actually. So that was the highlights of previous CarbonHack. Again, those are the previous sponsors. If you're interested in sponsoring the CarbonHack, please reach out to carbonhack@greensoftware.foundation, which is our mailing address for the hackathon. And the team will kind of reach out to you and send you any materials, any decks that you may need. We also have, if you know straight up you want to sponsor straight away, there's a form you can just go click and fill out, and that starts the whole process. You can also go to the website. Adam, if you want to quickly show the hackathon website link, and again, there's information on there, and you can actually click. There's a sponsor section and a button you can click, which brings up like sponsorship material, which you can then send to your organization and to if you want to sponsor. So I think that's enough about the hackathon itself, the structure, the planning, and the sponsorship. We will be building out the platform. It hasn't quite got ready yet, but we'll be building it out. We're going to run the entire hackathon on GitHub, which is why we're asking for your GitHub handle when you register. We're running everything in this hackathon is going to be run through GitHub. So you have to have a GitHub account, but we'll be releasing more details of that as we go along. And already the team are seeding this repository that we've got with ideas to help you figure out what it is you may want to build. Here we go. So that's the hackathon. What is Impact Framework? Some of you might have heard me talk about it. I'm very excited about Impact Framework. There's been more excitement about Impact Framework in the foundation than I'd say any other project that we've been working on. A lot of our projects are amazing, but the Impact Framework kind of just pulls everything together, and it's been a year in production until we get to this point. If you want to know a little bit more about it, we've got a website, if.greensoftware.foundation. That's a documentation website. It's run in public through GitHub, so you can find details about it on that GitHub repo. But let me just talk a little bit about what Impact Framework is. So let me get my notes up very quickly. Here we go. So Impact Framework is not something you install. This is all about measurement. Impact Framework is not something you install that somehow automatically measures your software. It's not something that scans your code or your infrastructure and spits out a number. At least not the default version, at least not what comes out of the box. It's much more lower level than that. There will be tools built in the future that do all of that stuff, and they'll all be built upon the foundational layer of Impact Framework. That's our belief. Impact Framework is much more important. It's much more nuanced, and it's much more complicated. To have software measurement be a mainstream activity, for this to be an industry with thousands of professionals working to decarbonize software, for businesses to grow and thrive in a commercial software environmental impact measurement ecosystem, we need to formalize software environmental impact measurement into a discipline with standards and with tooling. With Impact Framework, we are creating those standards, and it is that tooling. Impact Framework is a tool that helps you define a custom pipeline of algorithms that convert data you can observe about a running software system, such as CPU utilization, billing data, network transmission, memory usage, into environmental impacts like carbon, waste, water, whatever environmental impact you want to work with. Impact Framework is a framework to help all of that work together. It does so by chaining together, and we dig into this in more detail. I'll give you a very quick high-level summary. It does so by chaining together lots of smaller, what we call micro model plugins. The same way you can chain together in a Linux command line, you might chain lots of small commands together with a pipe operator, so that each of these little small commands do one thing and do that one thing really, really well. But by chaining them together, you can create really powerful commands and scripts. That's what Impact Framework does. It's chaining together all of these micro models to do a lot. And you can do the same with Impact Framework with model plugins. Each plugin helps a little bit in converting your observation into impacts. You define what you are calculating, the observations about your software, the model plugins that you want to use to convert those observations into impacts, how you want to chain everything together into something called a manifest file. Okay, And then finally, there is a CLI tool, which we call the impact engine. That is the thing that computes the manifest file, runs it through all those model plugins, and generates the impact. Through this approach, you can measure anything. You can take an observation of CPU utilization and craft a pipeline of micro model plugins together to convert that into a carbon impact. You might then swap out just one or two of those micro model plugins in the pipeline in order to change that pipeline from a carbon pipeline into a water pipeline, a waste pipeline, air quality, deaths. I'm going to be proposing, I really want to have a micro model produced in the hackathon, which tells you how many people are going to die because of your software product. Think about the behavior change that will drive. By chaining together lots of smaller micro model plugins, you can compute far more than if we created just a few monolith model plugins. Monolith models are things that just compute one impact from one observation. The power, what we've done is to create a standard for model plugins, a standard for these micro model plugins. Their function signature standardized, their parameters you pass in and we expect out are standardized. And through those standards, we've created an ecosystem where your model plugin that you create, as long as you adhere to those standards that we've defined in the impact framework, will just work seamlessly with everybody else's model plugin. And you can then just cherry pick the ones that you want to craft the pipeline you need for your application. The sum is much, much greater than the parts. Right now, we're in alpha. We just released alpha at our decarb event in November. We've built maybe 10 micro model plugins right now. And just with those 10, we've been able to compute and calculate so many different types of software applications, so many different types of from so many different types of observations. What we want to accomplish with this hackathon is to exponentially increase the number of these micro model plugins. So impact framework can be used to measure many more different types of software systems, many more different types of impacts, and from many more different types of observations. I'm going to show you a demo later, and I'm going to dive into some code here and there. But first, I have to explain just a couple of core concepts. You have to stick with me, and I will show you some code shortly. Next slide. So you may have heard me talk about, I've given this talk on 4Ms like multiple times over this last year. And actually, the definition of the 4Ms has actually evolved over time. But now it has kind of evolved to this point. So measurement, we say, has 4 core concepts. Software measurement has 4 core concepts. This has evolved over the three years we've been functioning in the foundation. There's so many conversations internally. There is a concept called mapping. There's a concept called modeling. There's simulation, which is so important. And there's monitoring. So I'm not going to go into monitoring today, but I'm going to just explain those other 3 very quickly. Let me just explain mapping to begin with. So what is an application? This is something, as we're developing, standards, such as the software carbon intensity standard, that kind of came into, it was a really big question. Like, when you're measuring a piece of software, what is a piece of software? It isn't a fridge. It's not a fridge. You can look at a fridge. You can see a fridge. If someone tries to sell you a fridge and it doesn't have a door, it should have a door. So you can say, well, I think I'm missing a door here. You can take the door off and weigh it, and you can take apart all of its components and kind of figure out how much emissions was caused by that door. Like, you can move your hand in space, and at some point it reaches fridge and it won't move any further. So where the edges and boundary of a fridge are. Software's not a fridge, right? What is the boundary for software? It's a kind of question we've been asking ourselves for a while. Like, at what point do you say, this is the edge of my software? I'm going to include the database. Actually, I'm not going to. I'm calling these APIs. Do I include that API when I measure this software's emissions? What is the boundary for software? And that process of figuring out what the boundary of the software is, that's what we call mapping in the kind of software measurement space. And this is why it's important. And let's say you have measured the impacts of your software and your application in year 1, and you calculate it as 3.3 grams per user. And then some things happen, and next year somebody reports, oh, we've gone down to 3.0 grams per user. If you don't know, if you're not transparent and very clear regarding what you've included in that calculation, you don't know whether that decrease was because of things that you've done or because you've accidentally gerrymandered or adjusted the border of that application. It's a very challenging issue, is what is the boundary of a piece of software? And that is what we call mapping. Oh, that's what we call mapping. Okay. And so I'm going to show you now the demo. Here we go. Right. Here we go. So I'm going to show you now an example of a manifest file for Impact Framework. So this is one of the manifest files that we've created. It's in the repo right now. It's from a case study that was built by one of the leads of Impact Framework, Srini, a while ago, and it's using a demo called MSFT eShopping. And how a manifest file in Impact Framework is a YAML file. It's fully transparent. It is the definition of everything that you're measuring in that piece of software. And you can see here at the bottom, there is a nodes in the graph. And you can see here, we're being very explicit. This computation, it includes a front end. It includes an app server. It includes a database server. It includes networking. This is what is being included when you give somebody that number. It's very transparent. It's very open. It's all there. It's like an LCA for software, very formalized, programmable LCA for software. This is very, very important. This is the mapping process. That's the first thing you do is you decide, what am I going to measure? And you're very transparent about it. And I'm going to talk about, I'm going to flip back to the slides now. I'm going to talk about the next thing, because how do you take that mapping? You now have decided what it is you want to measure. How do you actually convert those? How do you actually measure those things? And to do that, you actually have to do modeling. So this is a really great quote. I love this quote. All models are wrong. Some models are useful. If you listen to our podcast, Chris Adams, he introduced me to this quote. I think it's a great quote. Everything you do in Impact Framework is using a model. It does not do direct measurement. It's got nothing to do with direct. It's not measuring electrons anywhere. It's modeling. Everything is a model in Impact Framework. That means the models are going to be wrong. Okay, all models are not fully accurate. They're pretty close, to be honest with you, but not fully accurate. Now, one of the things that we've learned is it doesn't matter. The benefits of modeling is so far outweighs the slight errors you'll get from not being direct measurement, and I'll explain that through here. So all models are wrong, some models are useful, and the Impact Framework is very, very useful. So let me explain it a little bit more. I'm just going to quickly scan to see if I've got any questions. I don't see any questions that are jumping at me right now, but I'll scan it at the end. So everything is a model. That's what we talk about. Everything's a model. We have these models which take an observation and turn it into an impact. So a model is just something that takes some inputs, it's some code, and it spits out some outputs. That's how we think about what a model plugin is in the Impact Framework. Now, technically, there's a little bit of language we actually create with micro models. You actually might create lots of intermediate values, which then turn into an impact. But effectively, you're taking an observation and you turn it into an impact. Now, there's some wonderful models that exist right now. We've actually built model plugins to them in the framework as it is right now. But we now call them monolith models. These are monolith models. These are models which take an observation and go all the way to an impact, to carbon. So there's quite a few now. There's actually 3 baked in our models repo, which take utilization and turn it into carbon. Each of them has lots of different assumptions that it's made in taking utilization to carbon. Some of those assumptions are very significant assumptions. There's other models which might take, for instance, billing data. There's a model right now, CCF, takes billing data and turns it into carbon. And one of the key learnings we've had in the development of Impact Framework over the last year is that monolith models have their place. They're very useful, especially if you just want to move quickly. But their adoption of them is limited. That's because every software component is unique. Every organization is unique. If there is an assumption that this monolith model is making, which your organization or your software system doesn't agree with, it just won't be used. Which is limiting the adoption. For instance, in this case, if I go back one, you have to convert that to energy at some point. You have to convert utilization to energy, and how do you do that? Like, what assumptions do you make converting utilization to energy? There's so many assumptions you have to make there. Vista, a wonderful organization, has made the assumption, they've taken the position, that you should be reporting primary energy. And that's a reasonable assumption. If that's what you want, is primary energy, that's a reasonable assumption. Other models will just tell you the energy as consumed by your CPU. If you're running on a cloud product, do you want to take into account PUE or how efficient the data center is? Do you want to take into account other aspects? It's not so straightforward. It's not so straightforward. Which is why with Impact Framework, what we've done is we're creating these things called micro models that we chain them together. Instead of having one big model which does everything, we break them up into smaller micro models, each of them which does one thing and does one thing very well. Just again, like a Linux command line, which pipes lots of small commands together to make a much more complicated one. That's how Impact Framework works. So for instance, you can have an energy model which takes utilization to energy, and it can be the one that you want. The assumption, it can be, you can pick one that has the assumptions that you want. You can build your own, which has your assumptions by just having micro models. You then, and this is where oftentimes a point of contention comes along with these monolith models, which is you need to take energy and you need to figure out, well, how clean or dirty was that electricity that energy was consumed from? There's a lot of assumptions here. There's question marks over whether you use the average emissions from the grid or whether you use marginal. Are you using a yearly average? Are you using something specific for that region for that time? There's lots of assumptions here. By not having a monolith modeling and having lots of smaller models chained together, you can choose whatever methodology that you want to use for grid emissions. You can use that one. And again, carbon, we've got models that we built in to take all that data and generate carbon according to the software carbon intensity specification, which is a standard that's been built inside the Green Software Foundation. You may want to use the GHG protocol. You may want to use another one. Like, it's up to you. By breaking things out into smaller micro models, it allows you to cherry pick and get just the calculation that you need for your software component. And how we've done that is by standardizing this interface, and by standardizing the interface, that's how you create this ecosystem where everything works together. So let me just now jump back into some code again. Yeah, here we go. So I'm now going to show you kind of how we use those pipelines here. So, and again, there's lots more content, and I'll be doing lots more sessions to kind of teach people how to use Impact Framework before the hackathon. So you will be learning a lot more, and I'll be doing live coding sessions. We'll be having weekly ones from the new year to explain a lot of how this works. I know this is new to a lot of people. This is new to pretty much everybody. It's to everybody apart from the people who've actually been working on Impact Framework. So you define these models, and models are just little bits of code that you can plug in to Impact Framework. They're actually separate, but you can just install them. Each one is like an atomic little thing that you can install independent of Impact Framework. You can build your own. There's ones you can cherry pick them out there, and we're using TypeScript in this example, but you can npm install them or install them. You can, I'll show you later, but you can write them in Python and other languages as well. These are the models that we're going to use to compute the emissions of these software components. Oh, I should say, I didn't mention it before, like this is just 4 here, but Impact Framework has been built in a way so you can have hundreds, thousands of these nodes, as complex or as granular as you may want to have. That's what we're building with Impact Framework. But let's just have a look at the front end here. You define what's called a pipeline of models. And this is, again, this is just these, each one of these models is a micro model, which takes one thing, one observation, and just adjusts it a little bit and then passes it to the next, to the next, to the next, to the next, to the next. And through chaining these together, we can take some inputs, which in this case, if you look at the inputs here, it's just CPU utilization. So this is an example of 0. And these are the inputs that we pass in. So you can have an array of these, and I'll show you another example later on. But that's how it works. By chaining, each of these is a micro model. And you can see here that for the front end, we picked this pipeline because this is what we wanted for this example. But actually, different software components might have different, this is a slightly different pipeline because we don't have the similar data. So with every single software component can have its own bespoke type of calculation to compute its impact, because that's what's necessary. If you don't need CPU utilization if you're computing network. For network, we need something else. Your network, you're going to need something which converts gigabytes to energy, or gigabyte transmission to carbon. That's how it works. That's why the pipeline of micro models is so useful and so important. Let me go into another example here just to show you one here. This is like a fuller example. I'm going to execute this one. So you can see it. So here we go. So here's a pipeline that we've built it's just for one virtual machine, one component. And we want to compute what is the carbon emissions of this one virtual machine that's running on Azure. How do we compute that? How do we get there? So the first thing we've got is we've got multiple different types of models, micro model plugins that we've added here, which will all work together to compute the impacts. Now, there's also configuration here, and I won't go through it today, but on future sessions and in the documentation, you can see how the configuration works. The important thing in here is impacts. These are the observations that you can observe about your running system. This is just has one observation. And in fact, the observation here is like, we don't even have any observations. We want you to go to Azure and get the CPU utilization for us. So that's what the first model plugin does. It's actually built by the Microsoft team now. So they built an Azure importer plugin. Now, just to show you how this works, I'm just going to comment the rest of these plugins out so you can see what happens. Effectively, all that's going on is that we're passing this array of data to Azure importer, and there's a standardized interface for that. All of these parameters are standardized. So if you're going to use this value, we have a file called units.yaml where all this is standardized. And then you just run impact engine, passing in this YAML file and an output YAML file. And it's basically taking this data and it's passing it to that model pipeline, and it'll give you a file which you can look at in a second. Let me just wait for it to execute. This is actually what Azure Importer is doing. It's actually making an API call to the Azure metrics database. If you're using Azure, you can get data from the Azure metrics database, and it's pulling out 4 of this virtual machine for a 1 hour period. I want a 5-minute buckets of utilization, and I'm going to use that to compute the carbon emissions on a 5-minute by 5-minute basis. So let me just see, the results are out there. So you can see here. Is this the right one? Did I call it results? Just want to double check I called it results. Yes, I did call it results. This is the one. So now it outputs a file, which is the same as the input file, but with an outputs node. And this now has an array of data. Now, this is all data which we got from Azure. So it tells us, what was the CPU utilization, the cloud vendor, memory utilization as well, which location it's running in, the instance type. You need all this data. You need all this data to compute carbon emissions. How duration, which is 5 minutes. And we've got this in a 5-minute bucket all the way through for an hour. So it's extracted all that information. That's all a model plugin is. It's just you give it some inputs and it gives us some outputs, and we've just standardized. All these values are standardized. If you're going to use this value, you have to use a standardized version of it. There are the Azure importer is the only one that's being built right now. And it's very minimal. It just returns VMs at the moment. It's very complex, it turns out, in order to extract data from an Azure metrics database. Yeah. So that's the only one that's being built at the moment. Great hackathon submission is, we call these things importer models. There's different types of model plugins. We call these importer model plugins. So we'd love for someone to go and create model plugins for Google Cloud, for Amazon, for IBM, for all the different cloud providers out there. Or even from open source solutions, Prometheus. We should have a Prometheus importer, right? There should be. This is one of the things we need to build, this ecosystem of plugins, and they're very, very, very yeah, it's very, very flexible. Let's go here. So I am on. Yes, so that's the result. Now what I need to do is that's not enough. I need to get to carbon. I'm not a carbon right now. All I have is utilization. How do I turn utilization into carbon? Well, I need to use a couple of other model plugins. Now, a couple of things I need to do. I've got an instance type. What is that? What is standard? This is a question. When you actually start computing this stuff, all you know from a cloud provider is standard B1S. What is that? What CPU is running underneath it? You need to know that information in order to convert it into carbon. So that's what cloud instance metadata does. It returns that cloud instance metadata. This is something that we've been maintaining because it's stunningly hard to find a database of this information. So we decided we're going to maintain this ourselves. So that's another way you can contribute to the hackathon is we only have data here for Azure. We need data here for all the clouds. And then how do you convert that into energy? Well, there's multiple models you can use. There's one here, Teeds curve. So Teeds is what we call Teeds curve is a great piece of work done by Benjamin Davies a couple of years ago to come up with a generic power curve, as long as you have a TDP value. So you can use these models. You can other ones. We've got other ones. We've got Boa Vista one. We've got CCF one. We've got an IEE one, which I'll show you in a second. There's multiple different choices you can make for taking utilization into energy, and they all have their own assumptions. They all have their pros. They all have their cons. You can pick the one that is best for your use case. So now I'm going to rerun this again, and it's passing all that data through those micro models, and it'll pump it out the other side. So now, if I scroll down to the bottom, now Cloud Instance metadata returns some great information. It returned, you actually don't know the specific CPU for some of these instances on Azure. You just get a range. It also tells you these CPUs have 64 or 32 cores, and we're using half of a core. I think that's important to know as well. It returns thermal design power, and it passes that all through, and then it generates an energy. So this is in kilowatt hours. So now we know for that 5-minute period, we converted utilization to kilowatt hours. So we're somewhere. But we still need to get that from there to carbon. And in order to do that, we've got a number of other models that we can use. Now, in this case, I'm assuming that the energy, I've hard-coded the energy, the grid intensity to 951. But we actually have a model for watt time. So if you want to use the watt time API, you can actually get the actual grid intensity of that energy at that moment in time in your specific location. But just for the demo, I've kind of just hard coded it here. But now, effectively, through a combination of all these models, what we can do with Impact Framework is we can then compute carbon. Let me go through all the way through there. And then here we go. So you can see, yep, that's in the results. And now we've taken that energy CPU. We then figured out the operational carbon, which operational carbon from an SCI perspective is the carbon from just the, not including the embodied carbon. We have got a very simple model to calculate embodied carbon, but that needs a lot of work because you have to provide so much of the data up front. It's not something where you can automatically figure it out from an instance type. But embodied carbon, we sum it all together. So for this 5-minute period, it is I forget. I've forgotten if this is kilos or grams. I think it's grams. So 0.009 grams was emitted for this 5-minute period. And if you're looking at it from an SEI perspective, an SEI score perspective, that is 32 grams per hour for this 5-minute period. That is how effectively Impact Framework works. It is a solution that helps you compute any impact that you want through the use of these micro models. And this demo is very simple, but you could like theoretically create something which, and you're not happy with an SEI calculation, as if there's a model which GHG, it can convert to GHG. If there's a model for water, I don't know. I haven't actually looked. I have to like really engage to figure out like how do you get from a utilization value to a water stress value. There's research in this area. One of the things we're looking for was people to take a look at that research and go, well, how do I implement that in micro models so people could actually compute it? Just to give you an example here, because all of this stuff is that the framework's written in JavaScript to TypeScript, but it doesn't stop you, it doesn't mean you have to write your models in TypeScript. If you can write in TypeScript, it'd be slightly faster. But for instance, there's a model here built with Intel called the IEE model, Intel Energy Estimator, which is a slightly more advanced, it's like TEEDS is very generic, and IEE will give you numbers for a specific CPU. And just to show you how that works over here, so IEE is what we call a shell model. And in fact, what it does is it calls a Python script. So you don't need to write your models in TypeScript. You can write your models in whatever language you need to run it in. As long as it can be executed as a command, it can work from within Impact Framework. So any language is open. You can build models in micro models in any specific language. I think that's it for the demo, actually. Yeah. If you go to the Impact Framework repository, you will see that there are lots of sample manifest files that you can use. If you go to the documentation website, if.greensoftware.foundation, we've got tutorials, we've got videos, we've got how-to guides, and again, it's alpha. So this is stuff that's we're still developing, and we're going to be running these live sessions up to the hackathon. And I'm going to be teaching and explaining and taking a use case and really trying to show people how to use Impact Framework to measure all different types of things, bringing in guests, experts in measurement, and just really starting to explore what's possible to measure with Impact Framework. I think that's everything I've got for the presentation. I just Adam, how should I go? Are there questions that I should address? There's been a lot of chat.
There has been a lot of chat. Asim, hello everyone. I've starred a few comments from people in the comments section, so maybe we can go through some of those.
Okay, so you can show an example model. I'll just show. Do I have any in here? I don't have any in here. So a model plugin is. Let me see. Is this? I have to share a different screen. Do you know what? I'm actually just going to share another browser window. I'm going to take you to the repository because that's probably the easiest way for you, and it will teach you how to where to go to find other information. Just give me 1 second. 1 second, because I just have to like. How do I make it smaller? For some reason, my mouse is. Oh, here we go. Here we go. Okay. GitHub. IF. Let me share a different screen. Do I have to? Do I remove this one, Adam, or just do I kind of present again? No, I probably have to stop. Okay, I have to stop my previous presentation. Share another screen. Oh, give me a second. I've got 2FA. I've got 2FA. I've got 2FA, and I don't know where my mobile is. Where's my mobile?
This.
Give me a second. I'm going to find my mobile.
Yeah, well, we've had quite a few comments as well on screen. So we've got comments from Klaus, who actually asked earlier, what is carbon CO2? So normally when we're talking carbon, we're talking CO2 equivalent. But actually, if you go to our Learn website, I did answer this in the chat as well, Klaus, you'll have noticed. We've got a Learn website, learn.greensoftware.foundation. And you can find out a bit more about that. So let's see what else we've had. Also, how much carbon did that impact engine query produce? I don't think we can answer that one today, but I had a few laughs in the room to that one. And yeah, there's been quite a few others as well. Rosemary, a really interesting one around how can everyone contribute to reducing carbon and sustainability without being labelled as greenwashing? So, Asim, I know you'll have an answer to this as well. But
okay, yeah, I think I've got a point there, but let me first very quickly show. Yeah, here we go. So there's a couple of repos. There's IF. The Green Software Foundation /IF is the main CLI tool. We also have another repository called IF Models. And again, this is all the documentation websites. I recommend taking a look there. And in here, we've got a number of the models that we've generated and some of the things that you just looked at. So here we go, cloud instance metadata. And so if you see it, it's basically to build a model plugin. We've built it using TypeScript. If you're doing it in TypeScript, we built it. You just have to implement a specific interface. It has a couple of different functions. It's got an execute function, which is what passes in the data, and it's got a configure function, which is basically just two functions: execute and configure. So you can see that basically is all you need in order to build a model plugin, a micro model plugin. The other thing that's kind of important is there is something called a units.yaml file. So that's just the function signature, but the values you're passing in, there's a file called units.yaml. So if you're using the word energy, you have to make sure that when you are pumping out a value, a string called energy, you have to make sure the units are the right units. A common issue that just breaks all the interoperability of all these models that exist right now is that somebody's pumping out pounds and another person's expecting kilograms. Someone's pumping out Fahrenheit, another person's expecting things. Someone's pumping out watt hours, another person's expecting kilowatt hours. That's all standardized. If you are pumping out energy, or it's kilowatt hours, so that means that when that value comes into your model, you can also expect 100% it's going to be kilowatt hours. That's the thing that we discovered. That's the simple solution that just blocks so much of this interoperability. Is people are not consistent in the value. So those are the two standardization aspects of model plugins. Is you just create something which extends this interface, extends those two functions, and then the parameters are passed in just have to conform to what's in units.yaml. That is how you build a model plugin. There is also, and we don't have great documentation on this yet, and that is something we're going to get to by the hackathon. This is if you're building in TypeScript. If you're building a model with, like, let's say Python, as I said, like another language, you have to build it as a shell command, as like a literal command line tool. And we pass in data via standard in, and we get data via standard out. And there's another kind of specification for, this is what you can expect coming in, and this is what we expect you coming back out. So there's a slightly different interface standard for what we call shell models or shell micro models. But again, that's the documentation is a little bit weak right now. We're gonna improve that before the hackathon. So there's lots of information there in the documentation site about that. Should we get the next question, or is another question?
There's quite a few. Yeah, we've got.
Go on.
So Ines has asked. I'm just doing these in the order that they received.
Go on.
So,
Yeah.
How is the impact framework linked to the green metrics tool? And is there a link?
Oh, this is the green metric tool from Green Coding. It's not. We haven't. It's how it could be linked to the green metrics tool is you could build a micro model plugin which can leverage some of that data. I know the green metrics tool. I don't know. I think it's a couple of components, but I also know it does have a model that they use to convert utilization or some other aspect to energy, if I remember rightly. That could be, as long as a model plugin was built that adheres to this interface that we've described, you can then use aspects of that within a framework with other model plugins. And that's the really, really important thing, is we need to get everybody to start playing well with each other. Somebody's got a serial port, someone's got a USB-C, someone's got a Thunder port, and we're trying to plug all these things together. by standardizing the interfaces, you can make that tool work with CCF, work with Vista, work with things that we've created, work with proprietary things that are being built inside organizations. That's the important thing. Yeah, so that's that.
Bit of a follow-up as well there. Does the impact framework actually run the software? Yeah.
No, it doesn't. It takes observations that you have gathered from a running system. So the challenge that we're trying to measure software which is running on thousands of servers across multiple data centers, up on-premise, off-premise, your front end. We're trying to measure the impact of your software. The only way we can do that is if you can gather observations about your running system and then take those observations and then convert them into impacts. So you don't have to install anything, but you do need to be able to gather observations about your running system. For instance, a website, some observations you might gather from a website are number of page views. That's an observation that you can gather. Then we need models that can take a page view and turn them into carbon impact. We know those models. There's models that exist out there. There's the CO2JS model, which we're building as well, which we're creating an interface to as well. So it's all about growing observations, which people are already. This is the important thing. Everybody's already gathering observations about their running systems. There's no organization out there which isn't running kind of large software product, which is already gathering this data. They just need help in order to take those observations and figure out what the impacts of them are. That's what impact framework's all about. Next question.
Next one from Christian. Are the community models somehow certifiable?
So one of the things we implement, so we've built models. Then if you go to IF models, that repo there, and what our commitment is IF. If you see a model that we've built and we've put in IF models, the Green Software Foundation is committed to maintaining those models and keeping them, maintaining them and kind of enhancing them. In the exploration of impact framework, we also built interfaces to other people's models. We built interfaces to Cloud Carbon Footprint. We built interfaces to Vista. We built interfaces to other models. And what time? We put that in a repo called unofficial models. And that means that we built it, we put it out there, leverage it, look at it, learn from it. But those aren't models that we will kind of commit to supporting, because ultimately we hope that those other organizations will then build and maintain those models themselves. And what was the question again? There's another bit to it. I don't know if you can come back. IEE. So this is interesting actually, because the IEE model that was built, that showed you right now, that's actually proprietary. It's only because to get access, and this is something that's important. We wanted to, if we live in a world where getting access to data is extremely challenging. There are organizations out there which want to help you to measure software, but you may have to sign an NDA. They may just give you the data for you personally in your use case. And that's what the IEE solution right now, as it is from Intel, is one of those proprietary solutions. So if you're an organization and you want to help people to understand how to measure your software, but you can't release the data fully without an NDA, you can use Impact Framework, because you just give your customer access to your model plugin. They sign an NDA, then they can use it. FYI, IEE from Intel is going to be open source, so we're working with them to kind of open source that solution. But right now, it's proprietary. So that's kind of one of the aspects of it. It's very exciting. As IEE, it was one of my projects at Intel, and I think I'm very excited about that solution. And the open sourcing of that solution is going to be very useful to the whole world.
Right, next one from Klaus, which is a more general question about how far along is the IF project in terms of completed and planned features. And that's the sort of point of the hack, isn't it? Really, is to move that along.
Yeah. So yes, it is alpha right now, and what we mean by alpha is we got it to the point where we got it out there so we can get feedback. By the time the hackathon comes along, it is beta. Now, the goal for beta is to be able to handle a higher scale of we want to be able to handle like hundreds and thousands of those component nodes. That's the goal. There are, and also, get a bit more functionality together so it's easier to do things like syncing of. I won't go into details. There's a quite complicated set of things. We want to aggregate the data up a tree, and also be able to synchronize data across a grid to make it easier for you to manage. There's a bunch of features we're building for beta. Ultimately, what we're trying to what the framework's functionality for beta is going to, we're locking down the model interface as much as possible, because that's the thing that we won't change from that point forward. As we increase features of the framework, whatever you build from a model perspective should still remain as we go along. So that's kind of what we're planning. There's a lot more features we're planning for the future, but we also want to see what people build in the hackathon, because we want to see what are the ideas that people contribute to. Are some of those things that maybe you want to learn from and kind of bake into the framework? So there's a lot of stuff planned, but right now, specifically for the hackathon, it's just developer experience. So we want to get much better logging and debugging, and so if there's an error, you can know exactly where in your manifest file the error is coming from, and handling a higher level of scale. And the other features are around making sure that we're very confident on the model interface, so that won't change, because we don't want to pull the rug from you after the hackathon and say, thank you for all these models you built. We had to change the interface. You have to update all your models. That's kind of where we're going from a feature perspective.
Cool. Next one's from our LinkedIn community. How do the cloud plugins handle regions and renewable energy differences between them?
So just to reiterate again, we're just building micro model plugins. So the Azure one that you saw, all that does, it does one thing, and it just does that one thing well, which is, given this name of my virtual machine, tell me, just extract from your database what the utilization is. It doesn't make any assumptions. It doesn't care what the renewable energy consumption is. For that, you will use another micro model plugin, and it can be whatever you want it to assume. If you use the what time micro model plugin that we've used, it uses the marginal emissions rate for your region and your time. But it's up to you. That's the thing. It's up to you to pick whatever you want. And so if you use the what time, obviously it factors in kind of what the renewable energy is and how clean is that electricity in that particular region. But again, you may want to, let's say your data center has a solar panel on the top. Do you want to include that? Do you not want to include that? Do you want to include PUE, like power, how efficient your data center is? These are all plugins, micro model plugins that you can generate and then slot into a pipeline to get you the calculation that you want. Hope that answers it.
We probably don't have 100% of the data that we want today, but it was interesting something I said on the podcast recently about data. The more we use data, the more demand there is for more data, and the more obvious it becomes to the hyperscale cloud providers this data is important. So
yes,
if we build it and we find the inevitable limitation, then it will be more obvious to Microsoft and Amazon and Google and all the others that they need to provide this. So.
I say we lead. Open source should lead the way. We should be building model plugins, and then if those model plugins become popular, that's a strong signal, as you say, to cloud providers. Everybody likes this approach. Please make this approach the one that you implement. Make this data available.
Brilliant. Thanks for that question. I'm just saying there's a few others. So this one's from Icky. It's a longer question.
Of software. Is there a method available to present the effects of software using Impact Framing in a manner that is easily comprehensive that you meant with the SCI and making it so to average end user? It's a very low level right now. I showed you a bunch of YAML files, and I got very excited about a bunch of YAML files, and that's what Impact Framework is. What we hope, and this is Impact Framework, is helping you to define the calculation methodology that works for you with a very standardized inputs and outputs. We perceive in the future people can build tooling on top of Impact Framework, which then maybe simplifies a lot of this data for others. I don't recommend, and the way the hackathon's structured right now, there's no prizes for building tooling on top of Impact Framework. And that's because things are going to change so much until we get to 1.0. Our goal is 1.0 for next year around COP29. And let us get to that 1.0 point. I would recommend get to that 1.0 point before you start building UIs and all this stuff on top of it. Just because, or build it, but at your own risk, because the models will be locked down, the model interface, but the rest of the interface might have some flexibility to it. And you might end up in a situation where you've built this user interface and in like 2-3 months time, it doesn't work. So, we might be a little bit too early for a UI at this moment in time. We're very much focusing just on the calculation layer, but we're building it. We don't have any plans to build any user interfaces on top of this. This is not what Impact Framework is. Impact Framework is that lower level interface, and we want a whole ecosystem of tooling to be built on top of it. But the calculation you want to use underneath it.
This is a little bit like having a home assistant IoT setup at home, where you've got, when everything starts out, the data keeps changing, the sources keep changing, the code breaks all the time. There's no pretty UI, but it does follow in time, and it's very much a community-driven thing. I wanted to go back to a question from Rosemary, which is much wider.
All right.
And I don't know how we can start answering this one, but I know you'll be interested in this.
So I find the whole term greenwashing to be a bit weird, really. It's kind of like it can be used in a way to paralyze action. And I think it's too, it's kind of more a question around like intention and motivation than anything else. So let me just be the way it was explained to me, and I thought was very interesting, is like when people are concerned about being labeled as greenwashing in the green software space, when you're actually talking about reducing energy and doing these other things, we are so far away from that spectrum of greenwashing, because we're actually doing stuff. Like greenwashing is this whole other end of the spectrum. So I don't really think anything. If you are measuring software, you are. There's no way I could say that is a way of greenwashing. What is so beautiful about the Impact Framework is that I don't envision a future where you use Impact Framework to generate this manifest file, you calculate a number, and then you just print the number out and you give people a number. That's not the future I want. The future I want is that you let's say you built a piece of software, you build a manifest file which measures that software according to all the assumptions that you're using that measurement, and you share the manifest file. You don't share the number, you share all of your working out, you share all of your assumptions, all of your data, all of the models that you used, how you structured it all together. You share all of that out. And then somebody else can come along and go, I appreciate what you've done. I can see the assumptions that you've made. I can see the coefficients that you've used. I can see why you use them. They're not perhaps the coefficients I would use. They're not the models I would use. I will fork your manifest file, and I've just readjusted it. And this is what I think your carbon emissions are, or your impacts are. That's the future I want. I want a future where you're not just taking a number as face value. You're being given all of the workings out, and you can then make your own judgment. And maybe a piece of software has 20 different values associated with it because multiple people have said, I prefer this type of calculation to this type of calculation. I want to look at primary energy. I don't want to look at the data center energy. I care about how much coal was burnt. This is the beautiful thing. And I think like through complete transparency, if you're completely transparent, which is what Impact Framework, the manifest file, forces you to be, if you're completely transparent, it just negates any greenwashing, because if you're intentionally making assumptions on coefficients that are too generous to you, your manifest file will expose that. right? So that's what it's all about. It's about transparent manifest files, about transparency. I want a future where every single software product in this world, whenever it gets released, you can click a link and see its manifest file, and you'll see how that organization has decided to calculate the software. You can see if you agree with it, and you can see actually my organization calculates it a little bit differently, and I'm going to adjust these values so it meets my organization's or my preferences. So that's yeah, I suppose that's my answer to that question.
Nice one. Yeah, it'll be an interesting world to see what happens next. I'm sure there is a future where you'll go on the app store and see
Yes.
a number next to your app, but that's a little way off, and that's not what we're trying to do today. But somewhere down the line,
we'll get there. I think that's a great. I think I want to go to the app store, not just see the number. I then want to click a link to see the manifest file.
Yeah, that's a bit. It's like here's the number and here's show you working, so people can actually go and see what the story is behind that. Yeah, I love that.
Yeah.
Okay, easy one from MK Bain. Is there a website for CarbonHack 24, please? Got a slide for that. And I've even got a link for that. Sign up for info. greensoft.org/hack/24. I don't know if you want to talk a bit about the timelines, because at the moment, Asim, we're just letting people register for information. And then I think January is when we're going to start facilitating teams to, really sort of sharing ideas and meet people that have got different talents, right?
Yeah, that's exactly right. So right now, just please pre-register. And we're not just we've got a nurture campaign, and we're going to be constantly contacting you with more information. Sorry?
Not too constantly.
Not too constantly, no. But this is what we did last year with the hackathon. It's like, to us, it's not important that people register. It's important that people build solutions, and we're very focused around that. So once you register, we've got a whole process by which we help you to build. Our goal is you build those solutions. That's our fully full. So please pre-register. The platform is coming mid-January. It's going to be a GitHub platform. We'll be using GitHub issues, discussions. You'll propose your projects on there. We'll help you find teams on there. There'll be ideas that we're seeding on there, because we know this is a very new thing. Like, maybe people are going to need some ideas and help in order to ideate what to build. So everything's coming, but please pre-register right now, and it'll be coming very shortly, next couple of weeks.
Amazing. I think that was it. There's been another question. Oh, there's been one last one from Klaus.
Okay, let's do one more.
But that's the last one, I think. Yeah.
Okay. So that's we haven't quite. That's one of the things that we haven't quite addressed, and I don't know if we'll address for the beta. But yes, right now, impact framework is really just a manifest file, like a snapshot. Like, this is the emissions, let's say, for the last month, and calculating that. One of the things we're working towards is, and I'm not too sure if it's going to come for the beta, rebuilding a manifest file where you can rerun every 5 minutes, and it just gets kind of the last 5 minutes worth of data, and then kind of you can get something more real time. It's not going to be every second, because that's just too much. The lowest level of granularity we say that is meaningful is about 5 minutes, because this is not going to be something which is going to help you understand what we call whether you're how to optimize a function is not what impact framework's all about. It's how to optimize an architecture with thousands of machines. That's what it's all about. So we want to get down to about 5 minutes. But you can go lower. It really depends. It depends on your specific use case. But we think about, the reason we say 5 minutes is because that's the lowest level granularity you can get grid emissions data from a grid is 5 minutes. So if you're trying to get to carbon, you won't get much you won't get much more finer you won't get much more accurate data going below 5 minutes if you're trying to get carbon from that environment. But there are other use cases where you might want to go every 10 seconds, but you won't. Anyway, that's a complicated thing. I won't go into it now. Oh,
we're not having another demo. There we go.
Yeah, no demo. Yeah.
Cool.
And so we'll be running many more of these live sessions. And each session we're going to go and I'm going to be bringing people in. We're going to be going over the hackathon, obviously, but then diving deeper and deeper into specific examples. If you've got questions, post them. when the site's live, and we'll try and answer them on those sessions. And that's a link to the next session. So if you want to register for the next session, you can go to this link and register. It's the 8th of January, isn't it? Yeah.
I think the same time. We're not 100% sure, but roughly the same time. And it is. This has been recorded. So if you did RSVP, then you will get an email. You will have got an email with the link to join this live, but you can also watch this back again if you want to.
Awesome.
Cool.
Wonderful. Brilliant. I think that's it, Adam. Yeah.
That is it. Yeah. Thank you very much, Asim. That was really cool. We had lots of brilliant comments. Thanks everyone for joining. We're going to take a little break for the festive period, but we'll be back very early in 2024. So in the meantime, sign up for information, and you'll get regular updates, and we'll start matchmaking your team, or you can put your own team together, of course, and start exchanging ideas in early January. Thanks very much.
Wonderful. Thank you all.